Hello students, welcome back. So we are doing exercise 7C, isn't it? From indices. So we have completed till question number 3 in our previous videos, and today we'll start from question number 4 onward. Okay, so let's begin. So this is an equation given to us and we are asked to find the value of x plus y. This is the equation and we are asked to find the value of x plus y. Okay. So first we find the values of x and y, and then we add up to find the value of x plus y. So let's do this. Or a to the power minus 1 into b square whole upon a square into b to the power minus 4 whole to the power 7, isn't it? So you can write this as a to the power minus 1 power of a minus 1. We take this power a square to the numerator, and since the bases are same a and a, the power gets subtracted. That means plus 2 becomes minus 2. Okay, into b square we have in the numerator b square. Now we take b to the power minus 4 to the numerator, b same base, isn't it? So the power sign of the power changes, minus 4 changes to plus 4. Okay, so whole to the power 7 remains as it is, divided by, now what we do is the power is minus 5 here, so we take this numbers from the denominator to the numerator and number from numerator to denominator, so that this minus 5 changes to plus 5. Okay, so this becomes a to the power minus 2 into b cube whole upon a cube into b to the power minus 5. Now when we take this number from denominator to numerator and numerator to denominator, a to the power minus 2 b cube, we took this number to the numerator, a cube into b to the power minus 5, we took this number to the denominator. The sign of this power minus 5 changes to plus 5, equals to a to the power x into b to the power y. Okay, now a minus 1 minus 2 same sign, that means they will add up to become minus 3 into b to the power plus 2 plus 4 same sign, 4 plus 2 is 6 whole to the power 7. Now this divide we write as it is for the time being. Okay, now we have a minus 2, a to the power minus 2. Okay, first we change this. Okay, we just write multiplication sign here, a divide into multiplication sign. What happens, this number from the denominator goes to the numerator and number from the numerator comes down to the denominator. Okay, so a cube into b to the power minus 5, a minus 2 into b cube whole to the power 5. Now the sign of the power does not change because we changed here divide sign into sign. Okay, when we change the divide sign into sign, suppose we have a divided by b upon c. When we change this divide into sign, the c goes to the numerator, b comes down to the denominator. When we do this, the sign of the power does not change. C to the power minus 1, b to the power minus 1, this does not happen. Okay, similarly the sign of the power does not change here. Now let's put this power 7 individually. 7 3s are 21, a to the power minus 21 into b to the power 7 6 are 42. Okay, we multiply the powers because a to the power m whole to the power n means a to the power m into n, mn, isn't it? So a to the power m into n, mn, 7 3s are 21, b to the power 6 into 7, 6 7s are 42. Okay, now here a cube, we take this minus 2 to the numerator, plus 2. Okay, b to the power minus 5, we take this plus 3 to the numerator becomes minus 3 whole to the power 5. Now a to the power minus 21 into, okay, in the right hand side we have a to the power x into b to the power y equals to a to the power x into b to the power y. Okay, b to the power 42 this is 42 into, now a 3 plus 2 5, b to the power minus 5 minus 3 same sign, that means minus 8 whole to the power 5 equals to a to the power x into b to the power y, or a to the power minus 21 into b to the power 42 into this power. Now we put individually to a and b. Okay, a to the power 5 5s are 25, b to the power 8 5s are 40, minus 5 minus 8 into plus 5 is minus 40. Okay, equals to a to the power x into b to the power y, or now a same base means their power gets added, isn't it? So a to the power minus 21 plus 25, isn't it? B to the power 42, now minus 40 equals to a to the power, this b in b to the power 42 minus 40, okay, a to the power x into b to the power y. Now let me continue here. So a to the power minus 21 plus 25 means opposite sign, 25 is positive and 21 is negative, so 25 minus 21 is 4, isn't it? 5 minus 1 is 4. So a to the power 4, that means the sign of greater number plus comes here, plus 25, and b to the power plus 42 minus 40, plus 42 minus 40, different sign, so 42 minus 40 is 2, b square equals to a to the power x into b to the power y, which means you can see there is into sign in between a and b, isn't it? If there is plus or minus sign, you cannot apply this rule. Okay, if there is only into sign, then you can apply this rule. A to the power 4 equals to a to the power x, a and a same base, that means x equals to 4. If the bases are equal, then powers will be equal. A same base, their powers x and 4 will be equal. This can be done when there is into sign in between these two numbers. Okay, if there is plus sign or minus sign, we cannot apply this formula. So here the power of b is y and the power of b is 2 here, isn't it? Same base, that means y equals to 2. If the bases are equal, the powers will be equal. We got the value of x and y. X is 4, y is 2. Now we are asked to find the value of x plus y, isn't it? So therefore x plus y equals to x is 4 plus y is 2. So 4 plus 2 is 6. So this is the answer, isn't it? So I hope you got this. Now let's do question number 5. Okay, now let us do question number 5. So this is the equation given to us. From this equation we are asked to find the value of this 2 to the power 1 plus x. Okay, which means from this equation first we will find the value of x and then we can find the value of this number. Okay, so this is the given equation to us. We will find the value of x from this equation. Or let's first write this. Okay, since 3 to the power x plus 1 equals to 9 to the power x minus 3. This is the given equation to us, isn't it? 3 to the power x plus 1 equals to 9 to the power x minus 3. Or this can be written as 3 to the power x plus 1 equals to 9 means 3 squared into x minus 3. This x minus 3 is this x minus 3. Now 9 means 3 squared. 3 3s are 9. 3 squared means 9, isn't it? So since 3 and 3 same base, 3 and 3 bases are equal, that means the powers will be equal, isn't it? So we write x plus 1 equals to 2 into x, 2x minus 2 3s are 6. Powers will be equal. X plus 1 equals to 2 into x, 2x minus 2 3s are 6. Okay, their powers will be equal. Or plus x, we keep this here. Now we bring this minus to plus 2x left hand side, becomes minus 2x equals to minus 6 is already in the right hand side. We take this plus 1 to the right hand side, minus 1. Or x minus 2x is minus x, isn't it? Different sign. This x is positive, this x is negative. So 2x minus x is x. The sign of greater number comes here, minus x equals to minus 6 minus 1, same sign. So the number gets added, that is minus 7. Now minus minus cancels out, therefore x equals to 7. We found the value of x. Now let's find the value of this number, 2 to the power 1 plus x, isn't it? So value of 2 to the power 1 plus x means this equals to 2 to the power 1 plus x means 7. This means 2 to the power 1 plus 7 is 8. So 2 to the power 8 means 2 into 2 into 2 into 2 into 1, 2, 3, 4, 5, 6, 7, 8. 2 multiplied 8 times, isn't it? So 2 to the 4, 4 to the 8, 8 to the 16, 2 to the 4, 4 to the 8, 8 to the 16, 16 into 16, 16 into 16. So 16 is squared, isn't it? 16 squared. 16 into 16 means 16 squared. So I will teach you how to find the square of a number in a shortest possible way, okay? So first what we write is 1 squared means 1 ones are 1. Now we write 6 squared. 6 squared means 6 6 are 36, okay? Into, now we multiply these three numbers. 1 into 6, 6. 6 into 2, 12, okay? This means 6. 3 plus 2 is 5. This 1 plus 1 is 2. We add up this number, 256. The value of this is 256, okay? You can find the square of 16 by this way also. 16 into 16. 6 6 are 36. 6 1s are 6 plus 3 is 9 into 1 6 are 6, 1 1s are 1. So 6, 9 plus 6 is 15, 1 plus 1 is 2, 256. So this, if you do this, it will take a little more time. If you do by this method, it will take a shorter time saving, isn't it, in the examination time, okay? Let us learn this method properly. Let me give you some more examples. Suppose 25 square, we have 25 square. So how will you find the value of 25 square? First we square this 2. 2 squared is 4. 5 squared is 25. 5 5s are 25. We write as it is, okay? And after that we leave a number gap here. Now we multiply these three numbers. 2 5s are 10, 10 2s are 20. 2 5s are 10, 10 2s are 20. So 5, 2 plus 0 is 2, 4 plus 2 is 6, 625. So 17 squared, 1 squared is 1, 7 squared is 49, into 1 7 is 7, 7 2 is 14. So this 9 comes here, 4 4 8, 1 1 2, 289. Okay. Now suppose we have 13 squared, okay, 13 squared. So 1 squared is 1, 3 squared is 9, isn't it? So if the digit is single, 3 squared is 9, we have single digit number 9, isn't it? So we must make 2 digit number 09 into 1 3 is 3, 3 2 is 6, 1 3 is 3, 3 2 is 6, okay, 9 6 1, 169. If the digit is single, we make 2 digit number by adding 0, okay. Similarly, if we have 14 square, 14 is 4 4 is 16, 2 digit, isn't it? So if we have 52 squared, 52 squared, so 5 squared is 25. Now 2 squared is 4, isn't it? 2 squared is 4. Now we must write 2 digit number, so 04. 5 2 is 10, 10 2 is 20, okay. So 4 comes here straight away, 0, 5 plus 2 is 7, and this 2, 2704. You can find the square of any 2 digit number in this method. This is the shortest possible way, okay. So I hope you got this. This is not the thing which I wanted to teach you right now. This is the thing which I wanted to teach you, okay. Question number 5 of exercise 7c. So the answer for this number, the value of this number is 256, okay. I hope you got this. Now let's do question number 6. This is question number 6 from exercise 7c. So this is the given condition, these two are the given condition, and we are asked to find the value of x, okay. First condition is 2 to the power x equals to 4 to the power y equals to 8 to the power z. So this is the first condition, and the second condition is this equation, okay. So we are provided with these two conditions. We are asked to find the value of x now. So let's do this. First condition, since 2 to the power x equals to 4 to the power y equals to 8 to the power z, isn't it? This is the first condition. Or you can write this as 2 to the power x equals to 4 means 2 squared, isn't it? So 2 squared is 4, so y was already there, so we write y. 2 squared is 4, this y comes here as it is, equals to 8 to the power z, means 2 cubed means 8, 2 into 2 into 2, 2 into 2 into 2, 2 to the 4, 4 to the 8, 2 multiplied 3 times gives us 8, so 2 cubed means 8. Now we have z here, isn't it? So 2, 2 and 2 bases are equal. If the bases are equal, that means their power should be equal, isn't it? This means, therefore, you can write x equals to 2y equals to 3z. X equals to 2y equals to 3z, isn't it? So, first case, x equals to 2y, okay? And second case, x equals to 3z. If this equals to this equals to this, then you can write x equals to 2y and x equals to 3z. Because we are asked to find the value of x, so I keep x here, okay? X equals to 2y, first case, because this equals to this equals to this, means x equals to 2y and x equals to 3z. X equals to 3z. Now from here you can write y equals to, this x is already here. Now 2 comes down to the denominator of x by cross multiplication, isn't it? So 2 comes down, okay? So y equals to x by 2, this is the first what we need, okay, the value of y. And here z equals to x is already in the left hand side. Now 3 comes down, okay, to the denominator. So z equals to x by 3. So wherever we see y, we put x by 2, and wherever we see z, we put x by 3, okay? Now second condition given to us is, since 1 by 2x plus 1 by 4y plus 1 by 8z equals to 4. This is the second condition. Now wherever we see y, we put x by 2. Wherever we see z, we put x by 3. So, or 1 by 2x, we write as it is, plus 1 by 4 into y. Instead of y, x by 2. X by 2 plus 1 by 8z. 8 into z. Z means x by 3. X by 3. Now 2 1s are 2, 2 2s are 4. This means 1 by 2x plus this is 1 by 2x, 1 by 2x plus 1 by 2 into x, 2x, isn't it? 1 by 2x, okay, 2 into x, 2x, because 2 1s are 2, 2 2s are 4, 2 remains here, 2 into x, 2x, plus this 3 goes to the numerator, okay? If a upon b upon c, then this c goes to the numerator. This becomes a into c by b, isn't it? So a into c is ac upon b. If there is 2 times upon, then the last number in the denominator goes to the numerator. A into c by b. B upon c becomes into c by b, okay? So this 3 goes to the numerator. 3 1s are 3 upon 8 into x is 8x. So equals to 4 was there in the right hand side, isn't it? Or 1 by 2x plus 1 by 2x becomes 2 by 2x, isn't it? 1 by 2, same number, isn't it? A plus a becomes 2a, isn't it? C plus c becomes 2c. X plus x becomes 2x. In the similar way, 1 by 2x plus 1 by 2x becomes 2 by 2x, okay? Or you can find the LCM also. The 2x LCM will be 2x. So 2x into 1 gives us this. So 1 into 1, 1 plus this 2x into 1 gives us this 2x. So 1 into 1 is 1. 1 plus 1 is 2 upon 2x. Okay. So plus 3 upon 8x. 3 upon 8x equals to 4. Now this 2 and 2 gets cancelled. So we have 1 upon 1 into x is x. 1 upon x plus 3 upon 8x equals to 4. 1 upon x plus 3 upon 8x equals to 4. Okay, now the LCM of these two numbers, 8x and x, is 8x, isn't it? 8x, x and 8x. The LCM of x and 8x. If you do not know, you can find this way also. So x into 1 is x, x into 8 is 8x, isn't it? So the LCM is x into 1 into 8. X into 1, x, x into 8, 8x. The LCM is 8x. So x into 8 gives us 8x. X into 8 gives us 8x. That 8 into 1 is 8 plus 8x into 1 gives us this 8x. 8x into 1 is 8x. That 1 into 3 is 3 equals to 4. Or 8 plus 3 is 11 upon 8x equals to 4, isn't it? So let me continue this sum here. Okay. Now we have 11 upon 8x equals to 4, isn't it? We apply invertendo. Okay, invertendo means we take the number from denominator to numerator and number from numerator to denominator. Same thing we do here. We take the number from denominator to numerator and numerator to denominator. Whatever we do in the left hand side, we have to do the same thing in the right hand side as well. Okay, so 8x upon 11 or 8x upon 11 equals to 1 by 4. 1 by 4. Or x equals to 11 ones are 11 upon 8 fours are 32. So the value of x is 11 upon 32. Therefore x equals to 11 upon 32. I hope you got this. We cross multiply this. 11 ones are 11, 8 fours are 32. X we leave in the left hand side because we are asked to find the value of x. Okay, x we leave in the left hand side and we take this numbers in the right hand side. 11 ones are 11, 8 fours are 32. X equals to 11 by 32. So this is a proper fraction because the number in the denominator is greater than the numerator, so we need not change this into mixed fraction. Okay, so I hope you got this. We apply invertendo here. 8x goes to the numerator, 11 comes down to the denominator in the left hand side. 8x upon 11, 8x upon 11. The same thing, 1 goes to the numerator, 4 comes down to the denominator. 1 goes to the numerator, 4 comes down to the denominator. This is called invertendo. Okay, so this is the answer for question number 6. Now let us move on to the next question, question number 7. Okay, this is question number 7. So this is the given equation to us and we are asked to prove m minus n equals to 1. M minus n equals to 1. Okay, this is the given condition. We are asked to prove m minus n equals to 1. So let's do this. Now 9 to the power n can be written as 3 to the power 2n, isn't it? 3 squared, 3 3s are 9, 3 squared is 9, 9 means 3 squared and this n we write as it is. Okay, into 3 squared into 3 to the power n minus 27 means 3 cubed, isn't it? 3 cubed means 27. 3 into 3 into 3. When we multiply 3 times, 1, 2 and 3, 1, 2 and 3, we get 27. That means 3 cubed is 27. So this power n remains here. Okay. Now in the denominator we have 3m, 3 to the power m into 2 whole cube. This means 3 to the power m into 3 is 3m, m into 3 is 3m into 2 to the power 3. I put this cube to both the numbers individually. Okay, 3 cubed and 2 cubed equals to 3 to the power minus 3. Now 3 to the power 2n, 3 to the power 2n and 3 to the power n. See, the bases are equal, 3 and 3. Excuse me. Bases are equal, 3 to the power 2n, 3 to the power n. 3 and 3 bases are equal. That means the powers will be added. So 3 to the power 2n, 3 to the power 2n plus n, isn't it? 2n plus n plus n, 2n plus n into 3 squared minus 3 to the power 3n whole upon 3 to the power 3m into 2 cubed equals to 3 to the power minus 3. Okay, now 3 to the power 2n plus n is 3n. 3 to the power 2n plus n is 3n, isn't it? 2n plus n is 3n. Here also we have 3 to the power 3n, so we take the common 3 to the power 3n out. Okay, now within the bracket remains 3 to the power 3n is taken common, 2n plus n is 3n is taken common. Now 3 squared remains within the bracket, 3 squared minus this 3 to the power 3n is taken common, so 1 remains here. Are you getting me? 3 to the power 3n into 3 squared is 3 to the power 3n into 3 squared minus this minus 3 to the power 3n into 1 is 3 to the power 3n. In the denominator we have 3 to the power 3m, 3 to the power 3m into 2 cubed. 2 cubed means 8, isn't it? So let me continue here. 3 to the power 3n or 3 to the power 3n, 3 to the power 3n. 3 squared is 9, 3 squared is 9, 9 minus 1 is 8, isn't it? 3 3s are 9, 3 squared is 9, 9 minus 1 is 8 into 8 upon this into this, isn't it? This number 3 to the power 3n into this, bracket means into, so 3 squared minus 1 is 8, 3 to the power 3n into 8, okay, into 8. In the denominator we have 3 to the power 3m into 8, so in the right hand side we have 3 to the power minus 3, we should not forget this, isn't it? 3 to the power minus 3. So in the denominator we have 3 to the power m, 3 to the power 3m into 8 equals to 3 to the power minus 3. Okay, now this 8 and 8 can be cancelled, so we have 3 to the power 3n. Since this 3 and 3 same base, 3 and 3, so powers will be subtracted. 3n minus 3m, this 3 to the power 3m goes to the numerator, power plus 3m becomes minus 3m. Now this becomes minus 3m, isn't it? So this equals to 3 to the power minus 3. Now let's change the sign of the powers. Okay, we take, since 3 and 3 same base, we can do this also. Since 3 and 3 same base, 3 3 same base, okay, 3 and 3 same base means powers will be equal. So 3 into n minus m, 3 into n minus m equals to minus 3, isn't it? Let me do this properly again. 3n minus 3m equals to minus 3. Minus 3. Since 3 and 3 bases are equal, their powers 3n minus 3m equals to minus 3. Now let's take minus 3 common. Minus 3 common. Minus 3 is taken common. So you can see the numbers which are positive will become negative and the numbers which are negative will become positive when we take minus common. Okay, so this minus 3m will become plus m and plus 3n becomes minus n equals to minus 3, because if we multiply these numbers we should get this, isn't it? So minus 3 into plus m, minus into plus, the sign before m is plus, isn't it? So minus into plus is minus, 3 into m is 3m, minus into minus is plus, 3 into n is 3n. So when we take minus sign common out, the numbers which are negative becomes positive and the numbers which are positive becomes negative. Okay, so m minus n equals to minus 3 upon this minus 3 goes down here. So minus minus cancels, 3 1s are 3, 3 1s are 3, or m minus n equals to 1, isn't it? So this is what we were asked to prove, m minus n equals to 1, hence proved. Okay, I hope you got this. So this much for today. Thank you so much. Now I'll continue the remaining questions in the upcoming video. Okay, thank you.